got the invitation to speak here very last minute while I was away on tour / residency in Estonia, so I got back quickly, threw together a couple of things. Bear with me. So the project Lampyridae, developed by me and Matteo Marangoni, going through the materials I have to show, I came across the very first video we made for a competition call application that I'm going to play to you as an introduction. Oh, sorry, forgot to plug in the mini jack. All right, here we go again.
Lampyridae is a physical social network in the shape of a multisensory spatial environment in which participants act both as agents and spectators. Each participant is provided with a low-cost, handheld, battery-powered device called a Lampyrida. The Lampyrida is an artificial parasitical creature that delegates its locomotive functions to its carrier. The Lampyrida is capable of sensing light and sound signals through a microphone and a photodiode. Using an embedded processor, it analyzes incoming signals and generates responses that it emits via a directional loudspeaker and a high-power LED light. By emitting stimuli that the carrier perceives visually, orally, and haptically, the Lampyrida attempts to steer its carrier's behavior with the aim of moving within range of other Lampyridae. When two or more Lampyridae are at close enough range, they attempt to make contact, initiating communication patterns that result in streams of sound and light fluctuating in an unstable balance. The variable distribution of the Lampyridae in space gives rise to constantly changing fields of light and sound in which participants are immersed. In this process, cybernetic concepts developed within the realm of computer-simulated environments are embodied into the physical domain.
Spatial motion is entirely under control of the human partner of a Lampyrida, making the emergent atmosphere of this audiovisual playground highly dependent on their actions. A network of human and technological agents is created in which the communication is not transposed to an abstracted digital layer, but instead takes place in experiential space. Relatively simple technologies culminate in a work that transcends the level of technical achievement. Out of rational simplicity emerges poetical complexity experienced by bodily immersion. Commonly hidden in fiber optics or infrared emitters, optical pulse transmission is now made a sensible and playful medium. These were the buzzwords that the potential funders wanted to see. We didn't get the grant. But we did make the project. We're speaking 2013 here. We went through a long development and prototyping process. And the next video is from a presentation we had earlier this year in the Grote Kerk in Den Haag. Can I have a bit of light on me? Thank you. I'll hand a couple out now, just pass them through. Don't expect special things to happen. The behavior is tuned for 50 of them in the big room. I'm not sure what's going to happen right now. In the meantime, I'll keep talking. So Lampyridae, as Adrian said, is the scientific name for the fireflies. What's fascinating about these little bugs, well, they give light, but secondly, they have a remarkable capacity of synchronizing these light pulsations with swarms of hundreds or thousands of them. So imagine these tiny little insects. They seem to have ways to notice, sense their neighbors in the swarm, and synchronize very precisely, and it's a matter of milliseconds, their pulsations. A couple of starting points for this project is we wanted to create a piece, an audiovisual composition. We're artists, we're composers, that involves the visitors, the participants, as full active participants in this piece, and step away from or break away from the projection screen, projection of sound. We don't want our audience to look into a window to things that we project onto them. Are they disturbing, or is it okay? Tell me, please. Can you follow what I'm saying like this? All right. There's a little power switch on them. Flick it, and pass them on dead and silent.
Questions. Turn them off during on the questions. Right?
Thank you. What happened is they don't like the low tone of human voices. They prefer their locomotion partners that carry them around the space to be silent. And of course, my voice is now amplified in the space. They hear this, they don't like it, and they start screaming out, telling me to shut up. But we made them shut up. Too bad. One main point of this project is to make the audience, the visitors, an integral part of this ritual event. We're taking a whole lot of steps back in time to times where musical, theatrical performances were actually events that everyone was taking part in. Everyone was dancing with the musicians, with the performers, was singing along, was making music with them. And so somewhere along the way, this got lost. Most performances are given like this. Some people on the stage, they are the performers, and you in the audience seated are standing, and there's a big divide there. So this project is a try to get away from that. It's a development process of 2 years we went through, and there were really 3 main parallel tracks there. The first one being the prototyping and development of the body of the object. Actually, Meren, can you give a bit of light in the audience so they can actually see them now? The one track was the body prototyping, design, and construction. The second part was the electronics engineering. And the last, but certainly not least, is the actual coding of the behavior and the composition of it, because it's a quite a different thing to compose for an emergent system like this. So to reiterate that, each of these devices is an autonomous device. They have a little microcontroller embedded, and there is no digital network communication, so it's not controlled from a central computer. Already 10 minutes. Oh my God! I'm gonna flick through real quick through the slides I have. Interesting, maybe funny pictures of the process we had. Was very first formal prototype where we tried out making the speaker with horn techniques, and that was given informed by previous projects by Matteo. He uses a lot of horn speakers there. But this thing we tried to build ourselves sounded like not good. Actually, something like this sounded much better. So we started working with that idea. We went through a whole bunch of formal prototypes, thinking about how do we want our audience to hold this, to carry this. Finally, arriving at a sort of exoskeleton that is grabbing around the speaker cone, which we CAD designed, 3D printed, CNC milled the rib structure around it. And then I can go on for a long time about electronics engineering. And actually, you should ask me questions about this. And the question could be, how do you compose for such a thing? Which I will also not go on about the actual coding of this. We're doing quite advanced things there with frequency analysis of sound input to analyze sound triggers at certain pitches and so on. And yeah, this is running on the standard Arduino microprocessor, the ATML328. It's not trivial to pull this kind of high frequency analysis things off on there. Okay, that's it. Questions?